Hello and welcome to our webinar. Today we are going to talk about running high-performance Oracle databases on AWS. My name is Art Danielov. I'm CEO and CTO of FlashGrid. I will be the presenter today. And during the webinar, if you have any questions, please do not hesitate to email them to us at the address that is shown on the slide. Quick disclaimer, and please note that some of the information in this presentation is preliminary. So it might change over time. So let's first consider what are the what are the solutions available today on AWS for running Oracle databases. Well, first of all, it's Amazon RDS for Oracle. So let's see what performance can we get from Amazon RDS. If we look at the specs, we see that there are certain constraints on the storage performance. Specifically, the IOs per second are limited by 80,000 max, depending on the instance size that you choose. And the throughput in terms of megabytes per second is limited by roughly 2.4 gigabytes per second, which may be enough in many cases, but for large databases running some data warehouse type of applications or some mixed workloads, that might be not enough. So for example, to do a full table scan of 10 terabytes of data, it would take more than 1 hour. And also then there is the CPU capacity. So it is limited currently by 64 CPU cores, which also corresponds to 128 virtual CPUs. Now, we also have an option of running our Oracle databases on EC2. Now, let's look at what we have with EC2. Well, effectively, we are limited. In most cases, we're limited by the same performance constraints that the RDS has. And the reason for that is that effectively RDS also runs on EC2. Except that there is also the relatively new type of instances called high memory. Those are really large bare metal instances that have double the storage, the EBS storage throughput at 160K IOPS and 4.75 gigabytes per second. And they also have really large CPU size. But these instances require a 3-year reservation, upfront reservation, so you cannot just bring them up on demand. So it's quite a bit of commitment. But what if this storage throughput that we get from these EC2 instances is still not sufficient? What if we need higher storage throughput? And what if we cannot afford these huge high memory instances and the cost associated with them was the 3-year upfront commitment? So what else we can do here? Well, there are some good news. Well, first of all, what we can do is we can have up to 8 gigabytes per second of storage throughput and over 1 million IOPS by pooling together multiple storage nodes. So there are these new instance types, EC2 instance types called R5N, M5N, and I3EN, and also those same high memory instances that now have 100 gigabit per second network, which is quite a bit of improvement over what we had until recently. So it's 4x increase. And also our FlashGrid products called SkyCluster and SkyBase enable using those external storage nodes and presenting the disks attached to the external storage nodes to the main database server. So think of it as similar to the Exadata storage cells, except that here it's all on EC2, and we have 100 gig network between the database server and the storage servers. So specifically, if we decide to have 5 storage nodes of C5 18x large size, which gives us the highest EBS throughput at the lowest EC2 cost, we can get up 8 gigabytes per second of throughput. And by the way, this is also those 8 gigabytes per second for writes and 8 for reads. Now, the next question, though, is what about reliability of this solution or availability of it? What if one of those storage servers fails? Because now we have, instead of one server, we have 6 of them, and obviously the likelihood of an unexpected failure goes up, and the maintenance times also go up. So we can use mirroring across those storage nodes. We can configure them with normal redundancy, so that each block of data will have 2 copies across 2 storage servers. Again, it is for those of you who are familiar with how Exadata storage works, it is very similar concept here. So these are ASM, normal redundancy disk groups. And so if any of those storage servers goes down, there will be always an additional copy of the second copy of all the data blocks available on one of the other storage servers. So your database can keep running. So this is the first part of the possible solution. But we can actually have even higher storage throughput, up to 16 gigabytes per second, by using local SSDs that are available on I3EN instances. So those I3EN instances have, in addition to 100 gigabit per second network, they also have 60 terabytes of local SSDs. So it's effectively 8 local SSDs, 7.5 terabyte each. And those local SSDs are in addition to virtually unlimited EBS capacity that you can attach to those nodes. So what we can do with the FlashGrid SkyCluster and SkyBase products is we can combine the local SSDs and the EBS storage to get persistent and high performance storage at the same time. So with local SSDs, the main challenge with local SSDs is that they are not persistent. So if you read through Amazon's documentation, it tells you very explicitly that you should not be using it for valuable data, such as your Oracle database. And that's because if you switch off that instance, if you stop it, or if there is a failure and the instance has to move from one physical server to another, all the data on the local SSDs will be gone. So it is kind of similar to your part of your storage array failing, or one of your exadata storage cells failing. So the solution is to have another mirrored copy of data on EBS, on the persistent EBS storage volumes, but do all the reads from the local SSDs. So if you're familiar with how ASM works, it has this function called preferred read that allows you to select which fail groups you can read, your database would read from. So you're effectively writing to 2 copies of the data. One copy goes to those local, non-persistent, but very fast SSDs. The other copy goes to EBS volumes that are persistent, but not as fast. So your write performance is still effectively same as EBS, but your read performance now is the read performance of those local SSDs, because you will be reading that data from those very fast local SSDs. So again, if it is some sort of a data warehouse application or a mixed workload that requires high read storage throughput, this can be a good solution, as long as your fast data is up to 60 terabytes. Now, I have to mention here that you still can have a larger total size of your data files, because you can have some files that require, or some table spaces that require highest throughput on those local SSDs, while you can have less performance-intensive data files on EBS. So you can have, in total, you can have, let's say, over 100 terabytes of capacity. Now, there is also the ability to do this in the SkyCluster environment, where you have an Oracle RAC cluster effectively, and you have those local SSDs on separate nodes and EBS volumes on separate nodes. So that's in either case, whether it's single instance or RAC, the idea is the same. Your writes go to those local SSDs and EBS volumes, and the reads come from the local SSDs. Now, when it comes to even higher storage throughput requirements, or the CPU capacity requirements that exceed the capabilities of a single EC2 instance, the possible solution here is using our SkyCluster product that runs Oracle RAC and aggregates the network and storage throughput of multiple database nodes and multiple storage nodes. In this configuration, we can leverage the 100 gigabit network again and have up to 8 gigabytes per second of storage throughput per RAC database node, which means, like, in case of 8 nodes, 8-node configuration, which is pretty large, can be 64 gigabytes per second in total of storage throughput. And the storage servers can have a combination of either EBS volumes or local SSDs, or both. And of course, your CPU capacity also scales as you add more database nodes. So you don't really have to use, in such case, the largest 224 core instances that you have to reserve for up to for 3 years upfront. You can use some more on-demand instances, which makes it more practical in many cases. Now, let me give you some background about the two products, the SkyBase and the SkyCluster, that enable these high-performance architectures. So SkyCluster is an engineered cloud system that is based on EC2 and that enables running Oracle RAC with 2, 3, or more database nodes. Like I mentioned, it allows you to use EBS storage or local SSDs or the combination of both. And it is delivered as infrastructure as code appliance effectively that you can deploy in your EC2 account with just a few mouse clicks. It allows you to run not just high performance databases, but also databases that require high availability because, well, with Oracle RAC, you have high availability of compute, and we also provide high availability for storage. SkyBase, which is a new product and is currently in preview, is also an engineered cloud system based on EC2, and it has the same storage options. And it's also deployed as infrastructure as code with very quick deployment. But it is targeted at single instance Oracle databases. The benefit of using this SkyBase compared to RDS is that you have full control and you can get those additional high performance options. While compared to just build your own type of approach on EC2, you get the easy deployment and all those high performance options that are otherwise not available to you. In terms of compatibility of these two products, you can run Oracle database versions starting with 11.2 and all the way through the latest 19c. You have a choice of the Oracle Linux 7 or Red Hat 7 for your operating system. You can use all the standard Oracle tools such as Enterprise Manager, RMAN for backup, DataGuard for disaster recovery, Golden Gate for replication to different types of databases. We support various EC2 instance types, so not just the large ones that I told you about, but also smaller ones, and you can scale them up as needed. You can resize or downsize them depending on your application load. And we do support both the commercial and US government clouds. We try to make this product very DBA friendly, so you get the familiar environment with RAC in case you choose to use SkyCluster and Oracle ASM and Clusterware, all those familiar tools that I already mentioned. You get full control of all the database features and the patching process, so it's not database as a service again, it's more like an appliance that it's an open appliance that you can customize and configure for your needs. The patching process is pretty much standard. It's especially in case of EBS storage, it's very easy to expand its capacity. Just add additional EBS volumes, and you can add them to your ASM disk groups. And what's important, we also have a very knowledgeable technical support team with very deep Oracle expertise, so they can help you with the not just with the cloud parts, but also with database and ASM and clusterware related questions. In terms of security and control, you have full control of the database and the software and the operating system. The EC2 instances are deployed in your cloud account or your customer's cloud account. We as FlashGrid, we do not have access to your EC2 instances or data. The data is encrypted by EBS or by local SSDs if you choose to use local SSDs. And on top of that, you can also use Oracle transparent data encryption. And all of this comes with 24/7 support that covers the entire infrastructure stack. So that includes the FlashGrid software that is part of SkyBase and SkyCluster products. It also includes Oracle ASM and clusterware, as well as the underlying AWS components, EC2 instances, VPC networking, EBS or local SSD storage, and Linux components related to networking and storage. And we also can help you with performance assessment, sizing, tuning, troubleshooting, as long as your performance questions are related to the underlying infrastructure. We can help you analyze your AWR reports and give you specific suggestions of what you can do to achieve the optimal performance. And the good thing is that you can easily create your SkyCluster with Oracle RAC or SkyBase with single instance Oracle database using our launcher tool. It's an online tool that allows you to have a fully functional cluster or database server in less than 1 hour. Again, it's infrastructure as code deployment, but it is simplified with the online GUI tool that you can find on our website. It allows you to create a configuration once and then deploy multiple clusters or servers in a same or similar configuration. And most importantly, it eliminates the possible human errors. And these stacks are pretty complex. It's better to use what's been tested by many of our customers already. That is all I had to share today. Thank you very much for joining this webinar. And if you have any questions, please, we still have several minutes to accept those questions, and I will go through some of the questions that we have already received. And if you have a question you haven't sent it to us, please do it now. All right, so first question, what is the difference between SkyCluster and SkyBase? When do I need one or the other? Okay, so this is an easy one. SkyCluster is when you need a cluster, which is Oracle RAC cluster. Although you might also want to have a failover cluster, which does not necessarily have RAC, but utilizes the grid infrastructure clustering. So if that's what you need, then that's SkyCluster. If you just need a standalone database, single instance database, then you should use SkyBase. Is this limited to Oracle databases only? At this time, yes. Will you host and manage the databases for us on AWS? Well, like I mentioned already, these products run on EC2 and in your managed service provider account. So we do not host or manage the databases. We are effectively a software vendor. So if you have an in-house infrastructure and database teams, then you can do it on your own. If you prefer to use a managed service provider for either your cloud infrastructure maintenance or for your database maintenance, we are happy to work with your service provider. Can we replicate between SkyCluster and SkyBase for disaster recovery? Yes, absolutely. You can, because SkyCluster just runs regular RAC database, and SkyBase runs regular single instance database. As long as they are the same version, you can have data guard replication between them. And if you prefer to use a different tool for replication, you can also do that. Does SkyBase use AWS availability zones, and if so, how? Okay, SkyBase is a single instance database focused, so no, it does not use availability zones by itself. However, you can have two SkyBase databases in two different availability zones, or even in two different regions, and you can have data guard replication running between them, in either synchronous mode, which is possible in between availability zones, or in asynchronous mode between regions. And also, if you are concerned about HA and prefer to do an HA configuration across availability zones, then you can use SkyCluster, whether in RAC mode, you can do RAC 1 node, or you can run preferred instance, or you can just do a failover cluster. But for that, you need SkyCluster, not SkyBase. All right, I guess these are all the questions we had today. Very good questions. Thank you for sending them. And if you have any follow-up questions, please do not hesitate to send them to webinar@flashgrid.io. Thanks again for joining us today, and have a great day.